Okay, in this exercise we're going to graph and find the vertical and horizontal asymptotes for this function here. So in order to graph, the first thing that I'm going to do is like which is the domain of this value, which values can take x. So we realize that x cannot be minus 1 over 6 because when x is minus 1 over 6, this is going to become minus 1 plus 1 is going to be 0, and it's going to be indefinite. So in this case, f is not definite for the value minus 1 over 6, and the range is all numbers, all reals. So the first thing that I'm going to wonder is about the cut with the y. So it's going to be when x is equal to 0. So in this case I'm going to replace x by 0, and is going to be minus 25. So the first cut with y is when x is 0, y is going to be minus 25. On the other side, in order to find out the cut with x, I need to see when y is 0. So in this case, we're going to, instead of putting f of x, we're going to put y. This is dividing, so it's going to the other side multiplying, and we arrive to x squared minus 25. We pass the 25 to the other part because it was subtracting, and I can make a square root both sides, and I have x1 5 and x2 is going to be minus 5. So it means that we have minus 5 0 and 5 0. So there are two cuts with the y with x. Okay, so now we are going to see which in with interval it increases or it decreases. So this one is made by the first derivative. When the first derivative is positive, it means that the function is increasing or the y is decreasing. So here we have to derive this part. It's going to be by the division. So the denominator is going to be squared. First I have to do the derivative of this one, which is going to be 2x, and times this one without derivating. This is going to be minus derivative of the second, which is the denominator, so it's going to be just 6, times the other without derivating. So afterwards I just multiply 2x by these 2, and I multiply minus 6x squared by these 2. I just like sum the two values that I can sum, these two, and it's going to be this. So now if you see, given that this one is positive, okay, instead of minus 1 over 6 that we already see that is not contained in the domain, we know that there is always positive, so we have to focus on the numerator. It's going to be this one. So how do I know where this value is positive? So what I think is easiest is to graph it again, okay, in order to understand where the x is negative. So in this case we know already that this is like a parable because of this shape, of this form, ax squared plus bx plus z. So if the vertex is defined by minus v over 2a, so we already know that when the a is bigger than 0, so in this case like 6 is going to be convex, so it's going to be like open to upwards. So in this case we have the vertex, which is b is equal to 2 and a is equal to 6, so the vertex is going to be minus 1 over 6. So if I use this one in order to evaluate where y is equal to 0 in order to be the cut of the cuts for this parable, I figure out that b is 2, b is 2 here, a is 2, and c sorry, so here a is 6, okay, it's gonna be 6 here, but it doesn't matter too much because at the end we're gonna see that the square root is gonna be anyway, it's going to be negative. So this is going to be negative, so this means that there is no cut with x, okay, there is no cut with x about this parable. So this is again our first derivative, And here is the other function that I defined, which is this one, in order to see when it's positive or negative. So here, when j is equal to 0, in this case the cut with y is going to be 25. So here I can represent, but first I need to find out the vertex, because just I have one, so I need to find the reflex. So I just compute this value inside this g function. So here I compute, okay, and afterwards I find that this is going to be this so close to 25. So summarizing what we are doing, first we found the cut for the original formula function, and the second part that we are doing now, we are like representing when this function is increasing or decreasing. Okay, in order to see when it's decreasing or increasing, I want to find out where this is negative, because this is going to be the sign for all this fraction, because this one is going to be positive. So I'm wondering what about this one. So I'm doing like, I suppose it's a parable in order to understand better. So here I'm making the graph of this one. So this one is going to be minus 6 over this. This is the pair of the vertex, and it's going to be a, which is 6, is going to be positive, so it goes upward. So this one is the function. So why I did that? Because I realized that for all x this is positive. So what does it mean? All this to verify that this function, because this x for all x is positive, this is going to be a positive, and positive divided positive is bigger than 0, except for minus 1 over 6, which is not defined. So this function is always an increasing function. So we already know the cut, and now we know that this is an increasing function. So after that, we're going to find out the maximum and minimum values. So the maximum and minimum values are given when the first derivative is equal to 0. So we already know the first derivative, which is this one, and just to make equal to 0, this one which is divided, I'm going to pass to the other side to multiply, and this one is going to be the function. I need to find the zeros of this function, but we already know, because we did it before, that this function hasn't zeros, so there is no maximum and minimum. Afterwards, we're going to find out the concave and convex intervals. How do I do that? I make with this one, with the second derivative. So if the second derivative is positive, the function is convex, and on the opposite side is going to be concave. So afterwards I'm going to do this one, which is the first derivative, and I'm going to make the derivative of this one, the second. So this one is going to be elevated square, so it's going to be this one, elevated 4, elevated to 4. This one is going to be the first derivative of this one, which is going to be 12x plus 2 times this one without derivative. It's going to be this, minus the order is going to be this one without this one without deriving. So this is going to be 1 over 150. Remember that here is 150. Okay, 150, this one, and this one, the derivative of this one is going to be 2 times 6x plus 1, and after the derivative inside of this one, which is going to be 6, okay, and the other one without derivative. We don't make the derivative of this one, okay, and this one is 150. So after this one, I just multiply 6 times 2 is this one, and I'm factorize 2 of this 6x plus 1. After I can make the common factor between this and this, so I'm going to make 2 times this part. So if I multiply this by this, it's going to be this, and this by this is going to be exactly this one. Afterward, I just multiply the 6 by this one, and I make the subtraction and addition. So I cancel out these two and these two as well, and I arrive to this part. If you see, these both are similar, so I can just like this one, okay, minus 199 times 2 is this one, and I'm going to just cancel out, and I arrive to this one. So if you see, this one is always negative, so the sign of all fraction is going to be given by the result of this one. So when the denominator is negative, all this is positive, so this is going to be convex. But in the other side, the denominator is positive, this one is going to be negative, so it's going to be concave. So here we know that 6x plus 1 minus 0 is going to be that x, when it's smaller than minus 1 over 6, this value is going to be convex, and when it's larger than 1 minus 1 over 6, the value, this function is going to be concave. So we already have all information to graph. We have first that x, when is smaller than minus 1 over 6, is going to be convex. We know that the one cut is 0 point minus 25. There is another cut minus 5, 0, and there is another cut 5, 0. So we already know that this is an increasing function, and we know when the x is, here is larger than minus 1 over 6 is concave. So here we have, so first, here is the minus 1 over 6, which is not contained in the function. So this is a dotted line. It's going to be like our asymptote. So here is the minus 5, the first cut. So, and I know when it's like smaller than 1 over 6, this value is going to be convex. Okay, so it's going to be this. It's going to try to touch this, but it never touch. And the other side is minus 25 with 0 is the other cut. And this one is going to be 5, the other cut. And during this period, the function is concave, as you see here. So I hope it has worked, and have a great success with mathematics, and see you in the next video. Bye bye.